So first we have the 4 layers of the Earth, which are the inner core, which is 1,221 kilometers deep, the outer core, which is 2,300 kilometers deep, the mantle, which is 2,900 kilometers deep, and the thinnest layer, the crust, which is 30 kilometers. And we know this because of the Scottish physician named James Hutton, who came up with uniformitarianism, which is the idea that geologic processes that operated today also operated in the past. Next is seismic activity, which is shown with S and P waves. And the S waves are in blue and the P waves are in pink. P waves, which are the primary waves, can move through solids and liquids. And then S waves can only move through liquids. And the S waves are the secondary waves. And that's important because that's how we know what the core is made out of, because the core is made out of liquid iron and S waves can't go through it. So we know it's liquid, and then we know it's iron because when the P waves go through iron, they speed up. And so when that was tested, they did speed up. So that's how you know it was iron. Next is the magnetic fields. And the how the iron core like affects that. And so basically the iron core, or the dynamo, which is like the magnetic field generator, this exists within Earth's outer core, where liquid iron constantly moves as the planet cools, and this continuous motion can be converted into a magnetic field that will be sustained for billions of years. And then we know that it's an iron core for the same reasons, because of the S and P waves and how they are affected throughout there. So next is convection throughout the layers of the Earth. And the convection happens in the mantle, and it's when dense material will sink and less dense material rises to the top. And that's also with the hotter material will rise and the cooler material will sink. And then as it sinks, it'll start to heat up and it'll come back up to the top where it'll cool. And that's how you get the convection current. And then because of the convection in the mantle, it breaks up the plates in the lithosphere, which is like the upper part of the mantle and the crust. It breaks the plates apart and moves them around, and they will move any and everywhere in all different directions. And then the final one is plate tectonics. And they're shown because we started with Pangea, and that turned into like the planet we have now and where the continents are. And this happened because of the Mid-Atlantic Ridge. And at the Mid-Atlantic Ridge, there was, that's where like new oceanic plates are formed, and then they will come out on either side, and those will like push the older plates. And so every year we can like see just like they move very, very little every year. And that's because they're just getting pushed by the new plates coming up. And we know that's true because, once again, the convection, we know that that moves the plate tectonics, and that will cause them to move, and that makes what we have today. That's all.